Imagine this, you're standing on a hill, staring at the night sky, and every twinkling star feels like a story waiting to be told. But what if I told you that the solar system, our cosmic neighborhood, isn't just a flat disk of planets spinning around the sun? That above and below this familiar plane lies a universe so wild, so mind-bending, it'll change how you see everything. Buckle up, because today, we're diving into the cosmic layers surrounding our solar system, a journey that'll make you question what up and down even mean, from invisible bubbles to ancient explosions. This is a ride you won't want to miss. Hit that subscribe button and let's blast off. Let's start with what we know. Our solar system is home to 8 planets, from scorching Mercury to icy Neptune, all orbiting the sun. Picture it like a cosmic racetrack where the planets zip around in a flat plane called the Ecliptic. This isn't random, it's a legacy from 4.6 billion years ago, when a massive cloud of gas and dust collapsed to form the sun and its companions. The spinning motion of that cloud flattened it into a disc-like dough being spun into a pizza base. That's why the planets' orbits are mostly aligned, hugging the sun's equator. But here's where it gets interesting: not everything plays by the rules. Mercury's orbit is tilted by about 7 degrees, like a slightly off-kilter frisbee. Pluto, that rebellious dwarf planet, tilts a whopping 17 degrees. And comets, they're the cosmic daredevils swooping in from all angles, some nearly perpendicular to the ecliptic, like arrows piercing a spinning wheel. Why? Because many comets hail from far beyond the planets, from regions that don't care about our neat little plane. Now pause for a second. When we say above or below the solar system, what does that mean? On Earth, down is where gravity pulls us toward the ground. Up is the sky where birds soar and clouds drift. But in space, there's no ground, no universal up. An astronaut floating near Mars might see Earth below them, while another near Jupiter might see it above. It's all perspective. The ecliptic plane becomes our reference, like a cosmic ruler we use to define direction in a universe that laughs at our earthbound logic. This idea fascinated me because it forces us to rethink how we navigate reality. Growing up, I used to lie on my roof staring at the stars, assuming the universe had a top and bottom. But learning there's no such thing. It's like discovering the world is round all over again. The ecliptic isn't just a scientific concept, it's a reminder that our assumptions about the universe are often just human shortcuts. So what's out there beyond the planet's tidy orbits? First up, the Oort Cloud, one of the most mysterious structures in our cosmic backyard. Imagine a gigantic, invisible bubble wrapping the entire solar system, stretching so far it's a quarter of the way to Proxima Centauri, the nearest star. We're talking 50,000 to 100,000 times the distance from Earth to the Sun. That's a scale so vast it's hard to wrap your head around. The Oort Cloud isn't a flat disk like the planetary plane, it's a sphere surrounding us in every direction. It's made of trillions of icy chunks, frozen leftovers from the solar system's birth. Think water ice, ammonia, methane, stuff that could have become planets but didn't. Instead, these bits were flung outward by the gravitational slingshots of giants like Jupiter and Saturn. Some escaped forever, but others settled into long, looping orbits, forming this cosmic bubble. Here's the kicker: we've never seen the Oort Cloud directly. It's too far, too faint. So why do we think it's their comets? Those long-period comets that swing by every few thousand or million years, like Comet Hale-Bopp, which dazzled skywatchers in 1997, come from somewhere far beyond Neptune. Their orbits aren't flat, they come from all directions, suggesting a spherical source. That's the Oort Cloud's calling card. Let's put this in perspective with the story. In 1999, amateur astronomer Thomas Bopp was stargazing in Arizona when he spotted a fuzzy blob through his telescope. That blob became Comet Hale-Bopp, one of the brightest comets of the 20th century. Millions saw it a cosmic visitor from the Oort Cloud, reminding us that even the farthest reaches of our solar system can touch our lives. I remember my dad pointing it out to me as a kid saying, "That's from the edge of everything." It wasn't just a comet, it was a bridge to the unknown. The Oort Cloud challenges our imagination. It's not just a scientific theory, it's a symbol of how much we still don't know. If it exists and the evidence is strong, it's a reminder that our solar system isn't a neat little package. It's sprawling, messy, and connected to the wider cosmos in ways we're only beginning to understand. Zooming closer, we find another marvel, the heliosphere. This is a bubble of charged particles blasted out by the sun like a force field protecting the solar system. The sun's solar wind streams of protons and electrons pushes outward, carving out a space where our star's influence reigns supreme. But it's not a perfect sphere. As the solar system speeds through the galaxy at 828,000 kilometers per hour, the heliosphere gets squashed on one side and stretched on the other like a cosmic teardrop. The boundary where the solar wind slows and meets the interstellar medium gas and dust from the rest of the galaxy is called the heliopause. Beyond it lies true interstellar space where the sun's grip fades. NASA's Voyager probes launched in 1907 crossed this boundary in the 2010s, becoming humanity's first messengers to the stars. Voyager 2, for instance, hit the heliopause in 2018, sending back data that showed this isn't a sharp line but a messy, turbulent zone. Here's a real-life example to make this vivid. In 2012, Voyager 1's instruments detected a sudden drop in solar particles and a rise in galactic cosmic rays. Scientists realized it had left the heliosphere entering interstellar space over 18 billion kilometers from Earth. I remember reading about it as a teenager, feeling a mix of awe and pride. Those tiny probes, built with 1970s tech, were carrying a golden record with humanity's greetings, now drifting in a realm no human has touched. It's a testament to our curiosity reaching beyond the sun's embrace. The heliosphere isn't just a cool concept, it's our shield. It deflects harmful cosmic rays that could damage life on Earth. But it's also temporary. The sun's output changes over millions of years, and so does the heliosphere's shape. It's a dynamic living structure shaped by the dance between our star and the galaxy. Now let's go even farther. The solar system isn't floating in empty space, it's cruising through the local interstellar cloud, a patch of slightly denser gas and dust. But this cloud sits inside something even wilder, the local bubble. This is a massive cavity 300 light-years across where matter is scarcer than average. Imagine a cosmic bubble bath with our solar system inside one of the bubbles. How did this void form? Astronomers think it was blasted out by supernova explosions millions of years ago. These stellar deaths pushed gas and dust outward, creating a low-density cavity with denser walls at the edges. Our solar system is just passing through like a ship sailing through a calm patch of ocean. To make this relatable, think of the 1987 supernova SN 1987A, observed in a nearby galaxy. It was so bright it could be seen with the naked eye, a reminder of the explosive forces shaping our universe. The local bubble supernovae happened long before humans, but their legacy surrounds us. I once visited an observatory where astronomers showed me images of supernova remnants, glowing wisps of gas stretching across light years. It felt like staring into the past at events that carved the space we now call home. The local bubble is just one piece of the Milky Way's puzzle. Our galaxy isn't a flat disk either. It's got a bulging center spiral, arms, and a warped edge like a bent vinyl record. Surrounding it is the galactic halo, a spherical region of old stars, globular clusters, and maybe dark matter. This halo stretches far above and below the galactic plane, showing again that up and down depend on where you're standing. So why should you care about all this? The solar system's layers, planets, Oort Cloud, Heliosphere, local bubble aren't just abstract science. They tell a story of connection. We're not a lonely island in space. We're part of a galactic ecosystem, moving, interacting, shaped by ancient events. Every comet, every particle in the heliosphere is a thread in a cosmic tapestry. This perspective humbles me. I used to think of the solar system as a static diagram in a textbook, planets in neat rows. But it's a live, dynamic, messy. And Earth, it's a miracle. Amidst supernovae, interstellar clouds, and icy comets, life emerged on this tiny rock. That's not just science, it's poetry. Here's the big lesson: the universe doesn't fit in a box. It's vast, chaotic, and full of surprises, from the Oort Cloud's icy embrace to the local bubble's ancient scars. But you don't need a telescope to feel its wonder. Next time you look at the stars, remember you're part of this cosmic dance on a planet that's a speck in a galaxy, yet somehow impossibly home to us. What blew your mind today? The Oort Cloud's invisible bubble, the heliosphere shield? Drop a comment and let me know. If this journey sparked your curiosity, smash that like button. It helps us keep exploring. Subscribe for more cosmic adventures and share this with a friend who loves the stars. Thanks for joining me. Until next time, keep looking up.